Everyone. So today we're going to kind of just review some of the things that we talked about from section 1.1, tiling the plane. So the first vocab word we talked about was region. And region is the interior or inside of a circle or the interior inside of a polygon. An area goes right with that. Region just kind of talks about where that shading happens. So for example, if I was to draw a circle and color it in, we could say that's the region. But area takes that a little bit farther, one step farther, and it becomes then the measurement that covers the region. So area is when we associate a number with it. And region or area is very specific because it wants to make sure that we have no gaps and no overlays. So everything has to be connected to find the area of it. We don't want two separate shapes. We want it all together in one spot. So we're going to go through and we're going to just talk about how can we draw two shapes that we know do not have the same area. Okay, I'm going to highlight this. We do not want them to have the same area. So maybe one will have an area of 5, another could have an area of 10. Maybe one could have an area of 3 and another could have an area of 7. It's whatever you want. And we know area is the measurement. Right here, we're measuring the amount of space. So when I look at this graph paper, one of the ways I can measure that space is just by counting squares. So I'm just going to start by drawing a shape. I'm going to draw my best attempt at a rectangle. Ignore my little bubble here. I'm going to call this shape A. Just going to give it a name so you know what I'm talking about. And I need to know what the area of this shape is. So I'm just going to count squares. 1, 2, 3, 4, 5, 6. So the area of this shape is 6. Because that's the space inside of it. Now, we also know that for a rectangle, area can equal length times width. This is for a rectangle. And because I drew a rectangle here, I could have also known that this was 3 and this was 2. And I could have done 3 times 2 to figure out that I would have gotten that 6. Okay, maybe for the next one, I'm going to draw another rectangle, but it's just going to be a little bit bigger this time. I'm going to call this one B. And again, I want the measurement. Area talks about the measurement of the inside. So all I'm doing is counting boxes. And it looks like for this guy, my measurement's going to be 12. Now, because this is also a rectangle, because I know area is length times width, I could have counted that, there's 4 units this way and 3 that way. I could have seen that that was also going to be 12 by doing 4 times 3. So, what I'm going to say is shape A has 6 squares inside. While shape B has 12 squares inside. Okay, let's take a look at our next one. Ooh, we have some more vocab words. A polygon is just a 2-dimensional figure. Just think of a shape. As long as it's a shape that fits on a piece of paper, not 3D, it's a polygon. Now, quadrilateral is a little bit more specific because it is a 4-sided figure. So think like your rectangles, your squares, your rhombuses, your trapezoids, anything with 4 sides, it's going to be a quadrilateral. Now, example 2 is going to ask us to draw 2 different quadrilaterals. So it has to have 4 sides, each with an area of 6 units, or 6 square units. I apologize about that. So this time it's a little different than example 1 because we want them to be the same. So I'm going to start by just drawing a nice rectangle, and I'm going to make it 2 by 3 because I know if I count that out, I'm going to get my 6. So here's my first one. So I also need to think what else is going to give me 6. Well, 2 times 3 gave me 6. What about 1 times 6? I could do one really long skinny. 1, 2, 3, 4, 5. Can I count? 1, 2, 3, 4, 5. One more. 6. That also works. 1, 2, 3. There we go. It has 4 sides just like the other one. So now I have, sorry, you might hear my dog barking in the background. Sorry about that. Now I have 2 shapes that each have 6 units. So I'm not sure how much you guys can hear through the computer. It is storming kind of bad outside, and my dog is not exactly a fan of storms. So if you hear her barking in the back, sorry about that. All right, so we both have 6 units. All right, the last example we're going to talk about is helping us understand that we can find the area between things, and we can do it by kind of splitting them up into different sections. So this is an L. It's not really quadrilateral. It's a polygon because it's a 2-dimensional shape, but it's got 1, 2, 3, 4, 5, 6 different sides. That's kind of a lot. So we're going to see if we can look at this shape in 2 different ways to find the area for it. So at first, you know what? If I kind of cut this off here, I can see that there are 2 shapes. Here's a rectangle. Here's a square. So what I'm going to do with that now, I'm going to find the area of both of these little pieces. So for this one, I have a 4 and a 10. 4 times 10 gives me 40. My area is 40. Oh, but I should have colored these so you could see. I took it and I just split it into shapes I know. I understand quadrilaterals. I take this weird L thing and I cut it into 2 pieces. I put 2 quadrilaterals in there. Well, gosh golly, I can get that way easier. Now I gotta find the area of this. And oh look, it's a square. 5 times 5 gives me 25. Now I still want the area of the entire thing, so what I'm going to do is I'm going to add these. 40 plus 25 equals 65. 65 square units. All right, so this is asking us to do this in 2 different ways. So I need to look at it again and see if there's another way I can break it down. And I can actually go this way. So then this is going to give me this little top piece here. Then it's also going to give me this little bottom piece. There we go. Now the only thing that can sometimes be tricky when you cut these pieces is you then end up with a lot of numbers. There's a 4, a 5, and a 10. If I'm looking at this piece right here, it's touching all these numbers, but only 2 of them are going to apply. The 5 talks about this piece. The 4 talks about this piece, and the 10 actually talks about the whole side. Since the 10 also talks about a piece of the purple, it's too much information, and I'm going to ignore him for now. I want 4 times 5, which gives me 20. Now I need to do the same thing with this purple rectangle down here. This 5 talks only about half of it. It doesn't cover the whole thing, so I'm not going to use him. But I have a 5 for my width and a 9 for my length. So 9 times 5 gives me that 45. So 20 plus 45 equals 65. 65 square units. All right, kiddos, that's all that we have for today. I will see you tomorrow.